So the probability of failure may be written now as Pf is equal to P of the argument in terms of the logarithmic scale of the ratio R over Q less than 0. Okay, so let us now define another variable or another argument that will be the basis for our reliability index beta. If we look into the figure on top, we can say that the logarithm of the ratio R over Q at this point. Okay, so we specify a point somewhere here and subtract it on the mean. Okay, subtract this point and the mean, we now get a value which is the difference of this value with that of the mean value here. Remember that we're just subtracting a random variable. Let's say this is x I with x mean. Okay, so it's just like subtracting xi minus x mean to get the distance, okay, from a certain point, certain value from that of the center of this curve. So we are actually just getting what you call the variance, no, the variance at this particular point I. So if this is your point I there. Okay, of course, our argument is now different. It's no longer the resistance, it's no longer Q, it's no longer R over Q, but it is the natural logarithm of R over Q. And that's why if we define a variable of concern, which is U, uh, equivalent to this variation divided by the standard deviation, okay, we can come up with another probability. So how do we transform now the probability of failure into the probability of having this argument, okay, being less than 0? So we simply transform, or we simply transpose this standard deviation. We multiply it by u there, we get this value here, and then we put this mean value of your natural logarithm r over q at the left side. So this is here, and we retain the natural logarithm of r over q, which is 1. Okay, so why did we do this? Because we want to get another argument, which is the reliability index coming from a definition of a variable u. So hence substituting now this in terms of these two expressions here, we just insert. Now we just insert it here, or this one here. So PF is simply P of this one. Okay, so we now have a different expression, but it's still the same in terms of the logarithmic argument ln r over q. Okay, so this is now our argument. So how do I come up with this? Because this is a shortcut. So we just distribute. No, the probability of failure is simply the probability of a different argument u. So they're just the same, but we make use of pu. The new argument is equivalent to a distribution of p of u. Okay, and then we just place the less than sign immediately after your argument there. That's why we put ln over rq, ln r over q, or rather mean on the right side. So we put this on the right side of 0. So 0 plus this one is actually negative, but I'll explain to you where the negative sign, how the negative sign vanishes. So this ln r over qm Okay, and then we get rid of your standard deviation. We just cross multiply it down to this sigma now of the standard deviation of the r over q argument, which is in the logarithmic scale. Okay, so instead of having now a limit 0, we now have a limit of the reliability index. Okay, so we're changing arguments because we want to change also the limit. So our limit here is setting, we set the limits to, instead of having a 0 limit there, set it to the limit of the reliability index. Okay, so this u here now can actually be related to this limit. So this limit now is actually your beta. So your beta now value is simply equivalent to the limit, which is the lowest possible value of ln r over qm divided by the standard deviation of ln, or the natural log of r over q, known as the reliability index, or simply the number of standard deviation from the origin that the mean of the natural logarithm r over q is. Okay, so let's go back to the sign here. Some of my students are looking into the transposition of this value. Why isn't this negative? Okay, the reason for that, class, is because for a failure to happen, we will talk more on the left side of the bell curve, which is here. No? So the bell curve is actually the failure of such statistical representation is based on the left side of the curve, and hence xi is always less than xm. Okay, so if that is true, then this has some sort of an error wherein the ln, or the ln of r over q mean, is always greater than uh, ln of r over q. That's why this becomes a negative sign, will indicate that this is simply greater, always greater. The mean is always greater than the sample value, or the value of the random variable for in consideration. So again, the negative sign there was simply removed for us to note that always the interpretation is such that your mean value is always greater the random value of the argument. So that's it for the probability analysis. So next video, I will discuss to you some comparisons of LRFD and ASD. Thank you very much.